This video is about break even, so we'll be looking at how to calculate the break even point or the break even output for a business, and also how to show this on a graph. And we'll also be looking at how you could evaluate the usefulness of conducting break even analysis to a business. Now, in our last video, when we were looking at costs of production, we had this situation with a coffee shop, and we put together this table with just these 4 columns here. So our units of output, our cups of coffee sold, our fixed costs, which in this case was £5,000, and so it was always £5,000 no matter how many cups of coffee we sell. We had our variable costs, which was £1.50 per cup of coffee, which we multiplied by the units of output in order to get our variable cost along each of the rows, and then we added them together to get our total costs. But we were kind of missing here one really important piece of information for that coffee shop, which is what they're actually selling their cups of coffee for. So it's costing them £1.50 per cup in order to make them, but then how much are they then selling those cups of coffee to their customers? So I've added an extra column here, imagining that we're selling our cups of coffee for £2.75 each. So costing us £1.50 to make, selling them for £2.75. And then to get our total sales revenue column, all we're doing is the selling price, £2.75, times by the units of output along each of the rows, similar to what we did with our variable costs. And that gives us our total sales revenue, all of the money coming in from those sales of cups of coffee for each of these rows moving down the table. And you can see early on in the table, we're going to be making a loss on those cups of coffee because we've got these fixed costs here that we've got to cover, and if we're only selling a handful of cups of coffee, then we're not going to be covering those fixed costs, even though each cup that we sell is giving us a contribution towards covering those fixed costs. The calculation for profit is going to be the total revenue, the sales revenue, minus the total costs. And so you can see here along these early units of output, the total costs are higher than the total revenue, so we're going to be making a loss. As we sell more and more and more cups of coffee, then we're doing more to cover those fixed costs, and then we're exceeding them, we're going past them, and we're starting to make a profit. Now this is where the idea of break even comes in, because the break even output is the level of output at which total revenue is equal to total costs. So you can see, like we said, at the early levels of output, the total cost is higher than the total sales revenue. At the later levels of output, the total cost is lower than the sales revenue. But at this point here on our table, you can see the total costs are exactly equal to the sales revenue, to the total revenue we're receiving from selling our cups of coffee. And that is therefore telling us that our break-even output in this example is 4,000 units, or 4,000 cups of coffee. That's how many cups of coffee we need to sell in order to cover all of our costs before we can even start to think about making a profit. So as we've seen there, we could use a table of information in order to show where our break-even output's going to be achieved, as we've seen with our coffee shop example. Now this is going to use some slightly different figures. We're not using the figures for the coffee shop anymore, but we could equally show the break-even output using a graph. And so we're just going to see how we can construct that graph now. So the first line which you could draw onto there really simply is your fixed cost line, because this graph is showing our units of output along our x-axis here and our sales and costs, so in pounds, plotted along our y-axis here. And we said that our fixed costs are costs that do not change directly with output, so it doesn't matter whether we're producing no output or whether we're producing 10,000 units of output, our fixed costs are going to remain the same. So they become this horizontal line here. Fixed costs are going to be unchanging. You can then think about what your variable cost line might look like. And the variable cost, because it varies directly with output, when you're not selling anything, your variable cost will be 0. And then you would construct this line by multiplying your variable cost per unit by the units of output, and you could plot a few of those points to then make your variable cost line, which is going to be this upward sloping line starting from 0. But actually that variable cost line isn't that important for showing the break-even output, and what you really need is your total cost line. And your total cost line is the fixed costs plus your variable costs. So it is important to have this line in order to be able to add that on to the fixed costs, which is then going to give you your total cost line. So that should be an upward sloping line which runs parallel to your variable cost line, but starts at the point of the fixed costs, because if you're not selling any output, then your costs are simply going to be your fixed costs, and you just add the variable cost each of these stages to get your total cost line. And now, so we just need one more line onto that graph, and that's going to be our sales revenue, our total revenue line. And the way that we're going to construct that is we're going to do our selling price multiplied by our units of output. So similar to how we did with our variable cost, but this time with the selling price. And the key thing here is that the total revenue line is going to be steeper than the variable cost line. And that is because you would hope, if you're running any sort of sensible business, you'd hope your selling price per unit is going to be higher than your variable cost per unit. And that means that this line is going to be steeper, and it's going to be kind of catching up with your total cost line. And your break-even point is going to be the point, just like we saw in the table, at which the total revenue is equal to the total cost. Before this point, in this area down here, you're going to be making losses because you're not covering those fixed costs with what you're selling. And after that point, you're going to be making profits. But at that point there, that point where total revenue is equal to total costs, you're going to be breaking even. And quite importantly, you wouldn't just circle that point, but you would read down to the x-axis, because the break-even point is really the break-even output. So it's how many units of output that you need to break even. So that's going to be in units, not pounds, read off that x-axis here. So in my graph, in this example, my break-even output is 5,000 units. So those two examples now, we've seen how we can show break-even output on a table, and we've seen how we can show break-even output on a graph. And now the last, and actually by far the quickest way we can use to calculate break-even output, is using a formula. And in order to do that, the first thing we need to kind of be aware of is this idea of contribution per unit. So that's how much each unit that we sell is contributing towards covering our fixed costs, and then potentially going beyond that and starting to make a profit. So going back to that coffee shop example that we had at the start, our contribution per unit wouldn't be the £2.75 that we're selling the cups of coffee for, because we've actually got to factor in the fact that it's costing us £1.50 per cup to make each of those cups of coffee. So each cup of coffee in that case would be contributing £1.25 towards covering our fixed costs, which were £5,000 in that case. And the way that I've worked that out is quite simply to take my selling price and minus my variable cost per unit. And that's your calculation for contribution per unit. And this is going to be really critical to calculating the break-even point, the break-even output, which we're going to get to in a moment. But the contribution per unit, the selling price, which in that example was £2.75, minus the variable cost per unit of £1.50 to give us our contribution per unit of £1.25. Each cup of coffee we sell is contributing £1.25 towards covering those £5,000 worth of fixed costs. Now, just before we get to that break-even calculation, there's a couple more formulas which could be useful going forward as well. So you might be asked to think about this idea of total contribution, which really simply, if you calculated your contribution per unit, it's just the contribution per unit times by the quantity of output that you're selling. So that's kind of how much all of the units that you are selling together are contributing towards covering your fixed costs, or then moving into profit. And then finally, you've got this calculation for profit. And profit is usually calculated by total revenue minus total cost. That's the really simple, basic calculation for working out profit. But you could also calculate it by doing your total contribution minus your fixed costs. Because in your total contribution, your variable costs have already been taken away. They've already been removed in that calculation for working out the contribution per unit. And so you then only need to take away your fixed costs to then find your profit. And I think the easiest way to explain that is probably just by looking at a quick example. So imagine you've got a company manufacturing coats, they're selling coats, and their fixed cost is £100,000. They're selling 5,000 coats for £60 per coat, and the variable cost of making each coat is £20. So first up, you've got your contribution per unit. So we're using this formula here, selling price minus variable cost per unit. So our selling price of £60 minus the variable cost of £20, which quite simply gives our contribution per unit of £40. Next, we could calculate our total contribution. So that's using this formula, contribution per unit times by the quantity sold. So our contribution per unit we've calculated here is £40 times our quantity of 5,000 coats, which is giving us a total contribution of £200,000. And then finally, we can calculate our profit using this formula, using our total contribution we've just worked out, £200,000 minus the £100,000, which are our fixed costs. That gives us a profit figure of £100,000. And you could go back and check that using the more standard formula for profit as well, using total revenue minus total cost. So to do that, you'd need to do the 5,000 coats times the selling price per coat, £60, to get your total revenue. And then you take away all of the costs together. So you take away the fixed costs of £100,000 plus the variable cost, the total variable cost, which would be 5,000 times £20, and that would give you the same figure of £100,000 for profit, but just a different way of calculating it. And so here we come to the most important formula of all then, which is the formula for actually calculating the break-even output. And so for this, you do your fixed costs divided by the contribution per unit. So really, really simple formula if you can remember it, and it will help you to calculate your break-even point, your break-even output. So quick reminder, the contribution per unit is the selling price minus the variable cost per unit. And so therefore, another way of looking at the break-even output formula is the fixed cost divided by the selling price minus the variable cost per unit, all in brackets together at the bottom of that formula. So for an example, that same coat company that we had, they've got fixed costs of £100,000. They're selling 5,000 coats, £60 each, and the variable cost of making each coat is £20. Those figures can now just be punched into that formula. So £100,000 fixed cost goes at the top, and the £60 selling price minus the £20 variable cost per unit goes at the bottom. So our calculation for the break-even output in that case, £100,000 divided by 60 minus 20 at the bottom of the formula to give you 2,500. Really, really critically, that's 2,500 coats, or you could put 2,500 units more generically, not 2,500 pounds. So it's the output that you need to produce in order to break even. So that's why we're putting it in units, not in pounds. Now that's great for you to be able to know as a business how many units of output you need to sell in order to be able to break even, but actually most businesses are going to want to go beyond that, and fairly significantly beyond that. They're going to want to be making a profit. So their actual output that they're producing is very likely to be higher than the break-even output. And this is where this idea of the margin of safety comes in. So the margin of safety is the amount by which we can afford for our quantity of output to fall before we start making losses. So again, quite an important thing to be able to know. And so the formula for working that out is the actual output minus your break-even output. So how much can you afford for what you're producing to fall before you kind of start to move into losses? And you can see that on the graph as well. You see our break-even output there. If it was 5,000 units on our graph, our actual output level, let's say maybe we're able to produce and sell 7,000 units, and so you've got that difference there between the two, which you can show on the graph. There's the margin of safety, or you could do your actual output of 7,000 units minus your break-even output of 5,000 units to give you a margin of safety in this case, which would be 2,000 units. One of the key things that these break-even charts and this break-even analysis helps us to do is to be able to look at the impact of changes in costs or revenue on how many units of output we need to sell in order to break even. So we'll have a look at how that would impact on some of the diagrams here now. So imagine we had an increase in fixed costs. So our fixed costs were to increase, then this horizontal line is going to move further up onto this axis here, and our graph is going to change to look something like this. And so now you've got higher fixed costs, so you need to sell more in order to break even. So on your graph, you can see your break even output would increase. If you were to have a decrease in fixed costs, then you would have the line going in the opposite direction. So your fixed cost line is now going to move downwards. Your total cost line now comes down with it as well, and so your break-even output decreases. You now need to sell fewer units of output in order to cover those fixed costs, and therefore in order to break even. This time, if our variable costs were to increase, then that's going to make our total cost line go steeper, and it means that our contribution per unit is going to be lower. We're going to have to sell more of those units in order now to cover the fixed costs, so our break-even output is going to move higher, and we're going to need to sell more units of output in order to break even. Again, now the other side to that is that if our variable costs were to decrease, then our total cost line is going to become a bit shallower, and now we're going to need to sell fewer units of output in order to break even. Another way to think about that is the variable cost decreasing increases the contribution per unit, and so each unit sold is contributing more towards covering those fixed costs, so fewer units of output need to be sold in order to break even. How about now if we were to increase our selling price? So each unit that we sell, we're now going to be selling for a higher price. Well, that's going to make our total sales, our total revenue line to become steeper. You can see on our diagram here that if the total revenue line becomes steeper, then the amount that we need to sell in order to break even is going to be reduced. If we're selling each unit of output for more, then this time our contribution per unit is going to be increased, and we cover our fixed costs more quickly, and so our break-even output comes down. And then finally, if we were to have a decrease in our selling price, then our total sales line is going to become shallower, which means that the break-even output is going to increase, our contribution per unit comes down, so we need to sell more units of output in order to cover those fixed costs and in order to break even. And so we've drawn the graphs, we've calculated break even using a formula, and we've done kind of the maths side of things. And the last thing you might have to do with break even is to do kind of a written analysis and evaluation of how useful break even is to a business, and what's the point of doing all this analysis. So I would say it's really, really useful because it helps us in that business planning process. So as a business, if you're starting out, I would say a really key piece of information for you is going to be how many units of output do you need to sell in order to start making a profit. That's going to be your aim. It's going to be your goal, is to make a profit. And so how much do you need to sell in order to break even, which is your first stage towards starting making a profit. So it's going to be a really crucial part of that planning process, which from there you can then use to help with your application for loans, and you can use it to monitor your progress and things like that as well. And as well as that, you've also got this what if analysis that you can do, which is kind of what we've just looked at, actually, looking at the changes in the cost and revenue data and how it's going to impact on our break-even graphs. And as a business, you might be thinking about changing your selling price. You might be thinking about increasing your selling price. And you would then want to think about, well, how's that going to impact on how much I'm going to need to sell in order to break even? So that's quite a useful piece of information to be able to use. You might also be expecting changes to happen to your fixed costs. You might know that your rent is going to increase. You might expect that maybe you might be able to negotiate with your suppliers and get a discount on your variable costs. And all of those things are going to have an impact on your break-even output, and you can play around with your formula, you can play around with your graphs and have a look at how it's therefore going to impact on your break-even output if any of those things were to change. Now, the other side to this is that break-even analysis is really quite a simplistic way of looking at a business's revenue and cost data, and it's based on a number of assumptions which don't actually tend to hold in real life. So it assumes that every unit of output is sold for exactly the same price. So we had our selling price as part of our break-even formula, which is the same. It's £2.75 or whatever we set our selling price as, whereas most businesses are going to sell a range of different products at a range of different prices, which then makes break even much more difficult to work out. It also assumes that our variable cost per unit is going to be unchanged across all output. So you can see we've got our quite linear variable cost line on our break-even graph. But in reality, you'll probably find that as you bought more and more and more units of output, your variable cost per unit is likely to come down because of economies of scale. As you buy in bulk, you can get discounts on buying in larger quantities. And so that then makes break even a little bit more difficult to calculate as well. And also it assumes that everything that we make, we sell in constructing that total sales line, where actually, again, in reality, you're likely to make some of your output, and that's going to maybe remain unsold and get wasted. So that's going to be costs that you've incurred, which you then don't get the sales side of it as well. And so for that reason, you've got a lot of limitations of break-even analysis that you can weigh against the usefulness. And I think a really good evaluative kind of judgment towards the end of an answer on break-even analysis when you're evaluating is you can have a discussion about the fact that it depends on the size of the business. If you think you're a really small startup business, this could be quite useful as a planning tool. You might be selling quite a narrow range of products. You might be buying the materials in relatively small quantities. That can be quite a useful tool for you to use. Whereas if you're a really large multinational business selling numbers of different products, huge ranges of output which you're operating on, then actually break-even analysis becomes a little bit less useful because things have become a little bit too complicated for this really kind of basic analysis.